Hi everyone, welcome back to the channel. My name is Omid. I'm an assistant professor of statistics. Today we're tackling a classic confusion, correlation versus causation. Just because two things happen together, it does not mean one causes the other. Correlation is simply a measure of how two things change together. When one goes up and the other thing tends to go up too, we say they are positively correlated. Causation, on the other hand, is much stronger. It means that one leads to another. For example, smoking causes lung cancer. That's not just correlation, it's proven through years of evidence. Here's another example. In the summer, both ice cream sales and drowning cases increase. They are correlated, but obviously one does not cause the other. So what's the real cause? It could be hot weather. This is a great example of a confounding variable, where something else explaining the pattern. Here's another example. Early studies show people who drank more coffee had more heart disease. Some might think coffee caused it, but it turned out that people under stress drank more coffee and also had higher risk. So once researchers adjusted for stress, the link disappeared. That's correlation, not causation. To test for causation, researchers often run randomized control trials where groups are carefully compared. Observational studies, such as surveys, can only show association, not proof of cause. So always be skeptical when we see headlines like eating chocolate makes you smarter. Correlation doesn't equal causation. Without careful design, we cannot tell what's really driving the result. Here's another example. If we see that people who exercise more have lower cholesterol, that's correlation. But if we run a controlled trial and assign some people to exercise and other not, and cholesterol improves, then we can infer causation. These books and websites offer examples of how to interpret relationship responsibly, especially in medical and public health research. So always ask, could something else explain the relationship? That's the key to good scientific thinking and better health decisions. Thanks for watching. If you found this helpful, please subscribe for more simple practical lessons in Stack. See you next time.